Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's newsletter, we are going to take a look at failure mode and effects analysis. We're going to take a look at FMEA, and in particular, we're going to take a look at what FMEA is supposed to achieve as a generality, not necessarily the detail of the FMEA, that's for another video. But we're going to take a look at the two styles of FMEA. There's a design FMEA and there is a process FMEA. And we're going to take a look at these two techniques and how what they're supposed to do is to give you high fidelity control at the production level and make sure that you please the customer. And that's what these two things are designed to do. So we're going to talk through the principles. I'm going to use a silly little example, but it'll make a point as to how design FMEA and process FMEA are really supposed to work together. So the example we're going to take a look at, we're going to look at the idea of designing this remote control this is the remote control for my TV. So we're going to start with a design FMEA. Now, if you take a look at the form here, this is the FMEA form that we'd normally use. This is my FMEA form at a process level because that's normally the FMEAs that I'm teaching people. So I don't have one that's specifically for design. But in this first column here, the column wouldn't say process step. It would talk about the component, the part that's going into this particular TV remote control. So the form would be slightly different, but we would be starting with that first column, the part. Now you'll notice that the second column over says what is critical to quality. And this is really important. What the design FMEA is going to do, it's going to capture the designer's intent. Why did he design the product the way he did? Why did he come up with tolerances the way he has? That's what this thing's going to do. Not just come up with tolerances, not just come up with raw materials. It's going to come up with the reason why he did it. So if we take our remote control and we say, okay, what's one of the things that's critical to quality about the remote control? And we'll say that it's strength. We need this thing to be strong. Why do we need it to be strong? Because some fat guy who's more interested in watching the football than looking at the remote control might come along and sit on it on the sofa. So we have to have a certain strength to this, okay? So that's the critical to quality. So what's critical to quality about the plastic case? So that's what we'd be looking at. We go, it's the plastic case. Okay. What's critical to quality about that case? Strength. And of course we could put a value to this. Let's say we wanted to resist, I don't know, 50 kilograms. Not probably enough for a big fat guy, but 50 kilos maybe, okay? So that's the strength that we want. Now, as you work across the FMEA, of course, you're going to decide what risk this is and how much money you want to spend on this. Is it really important that we do this? So, and then of course at the end, you're going to say, okay, given that I do want to sort this out, what control am I going to put in place? So let's say we decide through the FMEA, this is important, we've got to do this, this is critical to quality, it's important to the customer, because of course, if you sit on it and destroy the remote control is not usable. It's not going to have a happy customer. So okay, so he decides now controls. Let's use this. He decides now what are his controls that he's going to put in place. Well, the controls he puts in place now, this is his design intent. So I've got to deliver this. Here's my design intent. So he decides to go for glass filled, I'm going to say glass filled nylon. Okay, so he decides that the raw material he's going to use is glass-filled nylon. And he decides that the wall thickness has got to be 1 millimeter. And because the thickness, there's a certain level of safety on this in terms of calculating its strength, etc. Maybe he doesn't have to put a particularly tight tolerance on it, so he says it's 1 millimeter plus or minus 0.1. Now that's his design intent. That's what the FMEA was designed to capture. It was designed to capture the thoughts of the designer, not just all the extraneous nonsense that could happen, like, I wonder if the customer might drop this down the toilet. I don't watch the TV on the toilet very often, but I wonder if they might drop it down the sink while they're doing the washing up and watching TV at the same time. That type of kind of strange event is what we typically capture in an FMEA. But that isn't what the FMEA is for. It's to capture your design intent. The customer needs this. How do we react? Well, we react with those two controls there. Now, the process FMEA has to deliver these two, because the process FMEA has got the same requirement. It's got a process step. So for the process FMEA, it won't say what's the component, it'll say what's the process step. You can see it on this form here. That's the way I've designed it, look. Process step. Then next to it, it says, what's critical to quality about this process step? Well, if this process step was the injection molding stage of the production process, what would be critical to quality? Well, that we use glass-filled nylon and that the wall thickness is held to a particular size and a particular tolerance. Okay, now what we're going to do, of course, is we're going to work across the process FMEA. And again now, we're going to decide whether this is important or not. And how do we decide if it's important? Well, we can look right across the design FMEA if we want to. You're not just going to figure this out off the top of your head here. These are manufacturing engineers. They don't know what the designer had in mind when he put that tolerance there. But if they look at the design FMEA, they'll know exactly why that tolerance is there. So they'll know how important this is. So again, we're going to get to the point where controls are needed. Okay, and let's say it's this. This is what we're talking about. The glass-filled nylon's relatively easy to control. But this, we're trying to control the plus or minus 0.1 of a millimeter. Now what some people put here, they will put we'll measure it, we'll gauge it. Now quite honestly, that's not a control. That's a filtering system. That's basically saying, we haven't got a clue how to do this. So because we don't know what we're doing, we're just going to grade all the crap out and throw it in the bin. Well, that's a terrible control. That's not a process control. It's just a gatekeeper to the rubbish that you're producing. No, process control. We're not going to measure it. We're going to figure out what settings exist on the molding machine that guarantee this. We're going to guarantee that this happens. Now we identify two controls. So we'll say temperature of the tool needs to be, I'm just going to make something up now, 150 degrees, and the tool must be cleaned weekly. And if I do those two things, I'll hit this. Now, when someone says, well, this is expensive, oh, and this, oh, we're going to have to buy a new control system to be able to achieve that. Do we really want to spend the money? Well, you can decide, because you can follow this. This thing follows right the way through to the point where the customer has got a particular requirement. Now that is the way FMEAs are supposed to work. When I'm looking at the bottom, and by the way, this is a proper control plan. Because what's it doing? It controls inputs. That's what a control plan does. It doesn't measure outputs. Measuring outputs is just a gatekeeper. It says, we don't know what we're doing, so we'll measure the crap out of it. That's rubbish. Control the inputs. We're going to do these two. Now, if you think that these two are expensive or difficult to do or whatever, you can now ask the question, why are we doing this? Well, you can go, because we're trying to maintain this specification in. Why are we trying to maintain this specification in? Because the customer wants this. Why does the customer want this? Because they're going to sit on it while they're watching the football. Is that important to the customer or not? Now you can decide whether you want to do this or not. How many times have you had to write a concession where you can't hit a tolerance and you don't know why the tolerance exists? It happens all the while. It used to happen all the while to me. Why did it happen all the while? Because we didn't have the design intent. We've got the design intent of the way we design the product. We've got the design intent of why we design the tolerance. And therefore, we've got the design intent of the way we design the process and why these two things exist. And now, of course, if we accept them, and I just put those in place, and I control the inputs, guess what? I never have to measure the output. I'm never going to measure this. I know these two control the bloody thing. That's control. That is a control plan. If you ever put check it here, check it, measure it, gauge it, inspect it, that's not a control plan. It's an inspection plan. What does FMEA do? If you really do it properly, it guarantees 0 defects and it guarantees happy customers. And if you get those two things, you will make pots and pots of money. That is what your FMEA is for. Okay, there's FMEA. Now, just before we finish the video, just a couple of things. If you'd like to know more about my thoughts about Six Sigma and FMEA, because there's some detail about how to do an FMEA, it's covered in this book. Drink tea and read the paper. Please buy the book if you're interested in finding out how to do this properly. Also, if you want to make any comments, you want to make an argument or discuss this any further, please leave some comments in the box below. That would be really helpful. And of course, the final thing is take the Six Sigma challenge. If you invite me in and I can't make your processes work better, if I can't make a technical problem go away inside your company, when we use Six Sigma, if I can't fix it, don't pay me. Take the Six Sigma challenge. But otherwise, leave some comments below. If you'd like some other videos to be made, tell me what you want in the comments and I'll make whatever video makes sense. So hopefully I'll hear from you soon.